We're live. Yes, we are. Okay. So welcome to yet another, webinar, right? Nick is about to join. Oh, here he is, right? Here's Nick. And we are going to talk about, what are we going to talk about? How to bring Terraform to Crossplane. How to inject it inside and do some cool stuff with it. That's my uneducated explanation of what we're going to do, right?
Right. So, yeah, we're mostly going to be showcasing today a experimental crossplane provider, which is going to be an interesting term because there's going to be a lot of providers involved here. But we have a crossplane provider for Terraform, which means you can use Crossplane to control Terraform, which in turn has its own providers. It's all kind of inception-y and a bit entangled. So over the last couple of weeks, I worked on as a little bit of a hack project, this thing called Provider Terraform. And it's pretty simple. It's effectively a scaffold around Terraform, the CLI tool. And it adds a new managed resource to Crossplane, which represents a Terraform workspace, i.e. Terraform module, some people might call it, or Terraform configuration, a big bundle of HCL effectively. So I think that this opens up some cool use cases. So this is sort of like an alternative to what I would think of as native Crossplane managed resources. So, you know, something like a Google Storage bucket or an Amazon RDS instance. I think the nice thing here is that we see a lot of folks recently who are sort of migrating away from Terraform to Crossplane, going for sort of leading into sort of the cloud native control plane approach to things. Sort of, I don't want to go into too much detail about the differences between Terraform and Crossplane. Victor's got some links that he's talked about that before. I've talked about that before. There's plenty of great places to go read about that. But the short version is there's similarities. They're both declarative. They both manage infrastructure, both have providers. The big difference is maybe that Terraform is sort of a command line tool that's sort of a one shot. You run Terraform, you tell it to go do some stuff, and it goes and does some stuff, and then it just sort of waits until next time you run it. Whereas Crossplane is an API-driven control plane. So with Crossplane, you sort of connect to its API, Kubernetes API, tell it how you want the world to be, and then it just sits there always reconciling, trying to make the world that way. So another thing that Crossplane does that's pretty cool that I know Victor talked about pretty recently is what we think of as the composition layer, which is I think, what was your video, Victor? Like shift left?
Shift left, yeah. It's about giving tools to ops to define how devs can have freedom to do things without going crazy.
Nice, yeah, that had a really good summary of this idea of what I think of as like separation of concerns between ops and devs, or platform teams and devs. So, my background's in SRE. I would, historically be in one of these teams who's trying to build a platform for my internal customers, for the engineers that I support, that I want to make more productive at my company. And Crossplane's really handy there because you can, as a platform team, kind of define your own APIs that have the opinions of your company, and you can get them out in front of your customers, your engineers. Customers is maybe a bit of a weird term for those folks if you haven't been in a sort of SRE or platform team. And then you can sort of define, hey, here's what Crossplane should actually do when someone says, hey, I want an Acme code bucket or an Acme code database or whatever abstraction and tool you're trying to give to your customers. So tying all this together, the most exciting thing I think about this new Terraform provider for Crossplane is that there's plenty of folks out there who have dipped their toes into trying to do this separation of concerns work with Terraform, and maybe have found that it doesn't provide the perfect interface for it, and that's why they want to move to Crossplane. And this gives them a bit of a migration path. So what I want to demonstrate today, and this is going to be a bit off the cuff because I've written the configuration but haven't ever tried it yet, so I'm sure it'll be broken and need a bit of debugging live on this webinar. But what I think is really cool here is I've got one example that's very simple and a bit contrived. But let's say you've got your company's opinionated Terraform module that represents storage buckets. This is how you do storage buckets historically. You want to give this out to your engineers and say, hey, if you want a bucket, this is what we think at Acme Code is how a bucket should be done. and you've tried that and it's not working super well, and you're interested in Crossplane, you really kind of want to try out this always on control plane API driven approach. So what Provider Terraform is going to let you do is build that API on top of a Terraform workspace, your existing Terraform that you kind of know and trust and have experience with, and try that out. But with your own opinionated abstraction on it that looks like a Crossplane, looks like a Kubernetes custom resource. And then slowly and consciously, you can move in the background the implementation over from Terraform to native Crossplane resources. So let's say you support 10 teams. You could, start all 10 out on using Crossplane, but backed by Terraform. So most of the logic is still sort of what you know and trust, and what's maybe battle hardened, and you're sort of just putting a little Crossplane interface to it to sort of try out a little bit of Crossplane without going all in. And then as you sort of get used to Crossplane and build some trust, you could then maybe move one team over to use native Crossplane resources sort of thing, learn, iterate on that, et cetera, and then eventually move everyone across. Does that kind of make sense, Victor?
Oh yeah, it makes perfect sense. I mean, it's a way. I think that actually many of the tools had that problem, right? A new tool emerges, it potentially wants to replace some other tools. That tool that has been used in a company for years, right? And years of using some tool means that no matter what you do, you have thousands of lines of something.
Yeah.
And it's very scary to say, hey, if you want to use this new thing, you need to actually throw it to trash and start from scratch. And then when you're finished, then only then you can start using it. We saw the same thing with Kubernetes, for example. I'm very much against lifting and shifting as a final state, right? But lifting and shifting is realistically necessary in bigger companies, especially in bigger companies, because if you cannot lift and shift, then what are you going to do, right? When are you going to rewrite everything? And then maybe 5 years later, you say, okay, now I'm ready. Now I can kind of embrace Kubernetes or whatever that is. So yeah, having a method to transition slowly or fast, right? But step by step is always a good thing.
Yeah. All right, let me get my screen set up here. And I think maybe an interesting first step. So as I mentioned before, there's definitely a couple of concepts in here that we're assuming folks are familiar with. This video does require you to have a little bit of familiarity with how Crossplane works, a little bit of familiarity with how Terraform works. So this is just the Provider Terraform repo.
If somebody doesn't have familiarity with Terraform, that somebody doesn't need this.
Yeah, right. That's
I can guarantee you that.
Very, very good point. So the scope of management for this new Crossplane managed resource. So Crossplane managed resources are the building blocks of Crossplane sort of thing. They're the bits that you can compose together into higher level constructs. So you want to build your bucket API for your company. What's really happening behind the scenes is it's using managed resources. So this adds a new managed resource that, as I mentioned before, is a Terraform workspace. So Terraform, I actually, while working on this, went and looked at their docs, and I believe the term for the directory where main.tf and the entry point to your Terraform is actually a Terraform configuration. But a lot of people call them modules, and the Terraform docs kind of refer to them as modules as well, like the root module. And then you can kind of have lenses into those modules, which is a workspace, which is kind of just like a named, almost a fork, you could say, or a branch of that workspace sort of thing. So that's what we use here. We call it a workspace. You could think of it as a module as well, or a configuration. And we provide two variants, both of which are kind of interesting here, the inline variant and the remote variant source for these workspaces. And they're really just, where does it come from? Where do I get my HCL and my Terraform logic from? So the one that you're looking at here is an example of the inline one. And in the inline one, as you can see, you say source inline. And then you can, this is useful for like really simple stuff. Let's say you just want to leverage Terraform to use a single resource. Maybe there's a resource that Crossplane doesn't support yet or something, or a resource that you have opinions about in Terraform that you're comfortable with. You could just drop in a little bit of HCL here inside your YAML. So, I wonder what the Venn diagram of people who like both YAML and HCL is, but they'll love this. Drop in a little bit of HCL there, and then Crossplane is actually going to use Terraform to make this happen. In this case, it's going to make a Google storage bucket. In the more likely case that you have a larger Terraform module that already exists out there somewhere, you can use the remote variant, which is here. So you can see the difference is here. This one, the source is remote. And instead of having all that HCL inline, it's basically just got a pointer off to any source that Terraform supports natively. So Terraform can initialize from remote sources. And that could be a Git repo or the HashiCorp registry, I think, or a bunch of other sources, like I think S3 buckets and things like that. So you can just specify one of those here as well. So, let's say you've got, your company's private GitHub or Git repo that's got your Terraform configuration. The module represents a bucket or a RDS or something like that. You can go point provider Terraform at that and say, hey, pull in this workspace and Crossplane, go apply it. So in and of itself, without composition and anything else on top of that, this is a little bit interesting because it sort of wraps Terraform to make it sort of an always-on open control plane. In the background, this provider literally just invokes the Terraform CLI in a loop in the background. It's not that fancy behind the scenes, but it does work pretty well. And this allows you to lean into this sort of give you a nice Kubernetes API to manage your Terraform. I believe that HashiCorp themselves have a Terraform operator that also applies workspaces that is kind of similar to this. But I think where this is more interesting and a bit of a different approach for Crossplane is when you consider composition on top of it. When you consider that you could use this workspace and mix and match it with native Crossplane resources. Again, I think the use case for that might be, let's say Crossplane had 9 out of 10 of the resources you need, but there's sort of a obscure one that there's a Terraform provider for and not yet a Crossplane provider for. You could go and use the Terraform one to sort of fill that gap. And the other big use case, as I mentioned before, is migrating from one to the other. So any questions, Victor, before I move on?
No, first I have questions, but first let's see Carlos' question.
Yeah, sure. Oh,
there you are. Read it.
What are the credential types supported for private Git repos, SSH keys, personal, etc., etc.? That is an excellent question, Carlos. So under the hood, there is actually a Terraform command called or Terraform flag to the init command. So when you start a Terraform, you init your repository. And Terraform actually supports doing Terraform init -- from module, or just minus from module, I think, and then you point it to a remote. I believe that's using HashiCorp, or it might be Mitchell Hashimoto's personal go-getter library behind the scenes. And this is a bit of a dodge to your question, but it's basically anything that library supports is supported here. I actually haven't personally yet tried private Git repos, so I'm not entirely sure. It may be unsupported, but basically whatever Terraform natively supports initializing a module from, this supports initializing a module from.
Okay.
So the good question, I'll have to get back to you.
Now it's my time. Theoretically, if I understand right, if there is external name, then this Terraform inside of Crossplane would pick on the existing resources. So if I created the resources using Terraform and then move that to Crossplane and I have the external name, would that pick it up?
Yep, exactly. You do need to be a little bit conscious. So obviously there's kind of so maybe 2 levels of migration here. Let's say first you're just running Terraform, the old-fashioned way from your CLI, and you've got a bunch of resources with names there, and then you want to add that into Crossplane using sort of this pattern with the remote Terraform. This is going to use Terraform remote state or Terraform state. So as long as you make sure to bring your Terraform state along with you to Crossplane, to the provider Terraform, then you're just going to be managing those same resources. It's going to be able to make those relationships just using normal Terraform state. So this provider actually isn't opinionated about Terraform state. It doesn't do anything magic to work to manage it for you. It effectively recommends that you, same as Terraform recommends, that you use a remote state backend with locking and all that good stuff. So there's a couple of different options there. You can imagine in this case where we're using Google, you might be using the Google storage backend that just goes and uses a Google bucket and keeps state in that. If you were using that and that was sort of configured in this Git repository here, then when you brought this into Crossplane management, it would keep using that. And then there's the next level of migration where you go from, okay, you've now got Crossplane, it's got this workspace managed resource, it's managing your Terraform for you. You want to actually go to native resources. And then that's exactly where you would use that external name annotation. So you would make sure to note what the names of your, let's say bucket or whatever you're migrating over or databases, and ensure to set the Crossplane external name annotation. And then Crossplane will adopt those things and start managing them, sort of thing. It's not, you do need to be a little bit conscious, right? You don't want Terraform and Crossplane both trying to manage them at the same time. You need to kind of stage it. You need to be careful about matching the configuration and whatnot. It is not a worry-free, completely automated system, but it's totally possible.
This is not a question, more like a comment from Niklaus. I'm butchering your name probably. Anyways, that Terraform operator only supports content executed from Terraform Cloud. And this is already more flexible than that. You already got the first thumbs up, Nick.
Nice. Thanks, Nicholas. All right. Do you think, Victor, should we try and work through a migration example that I put together?
Yeah, I mean, it's been already like 15 minutes and you haven't touched your keyboard.
Right. I was saying to Victor before, I actually have a new keyboard, so I'm going to blame any stumbling you see on the fact that I have just moved from using an Apple Magic Keyboard for 10 years to trying out my first mechanical keyboard, so I'm definitely not typing that well. All right, so on this terminal, I have just installed, what have I installed? A Kind cluster to go and run Crossplane. I don't even have Crossplane in yet. And we're going to try and work through an example that I just mentioned of sort of taking an existing Terraform module, bringing it into Crossplane, putting it behind a Crossplane composite resource abstraction, so you can sort of offer it as self-service to your engineers that you're supporting as an SRE or platform person. And then we're going to show how you can switch that over to a native Crossplane resource. So first, just let me just get Crossplane installed. Namespace and install.
Let me interrupt you for a second, Nick. Can you
make it
bigger?
Yes, I can. Good point.
There you go.
All right. So you can see in this Terraform examples, I'm going to go into the migrating from Terraform directory. And inside this package, I have keyboard. Made a little configuration here that is called migrating from Terraform. And what we're going to do here is, make one of these buckets. So this is a Crossplane composite resource that I've defined. I'll show you that in a second. It's a very simple one. It just represents a storage bucket, specifically a Google storage bucket. But there's two different implementations of this one. So the only parameter it has is the location. You can choose between the USA and Europe. But then there are two implementations that are selected, two different compositions, as we call them in Crossplane. One composition uses Terraform, and the other composition uses native Crossplane buckets to implement it. So this is that example of, you could start by start with your existing sort of Terraform bucket module that you give to all your customers, put that behind this composite resource, and then migrate people over once you sort of are comfortable with that to native Crossplane resources. So I don't want to push a configuration, I want to install a configuration. So I've packaged up this configuration. Configuration is basically just a bundle of a bunch of Crossplane configuration stuff that configures the Crossplane control plane. So that's going to do a few things. It's going to, when I install this configuration, it's going to install the definition of that bucket resource I just showed you. So it's going to teach Crossplane about this concept of a bucket composite resource.
I think we lost Nick. He'll probably be back in a second or 2 or 5, unless there he is. There's Nick. Nick, share your screen again.
Sorry about that.
We lost you. That's okay. I wasn't sure whether you lost connection or you realized that you're going to fail in your demo and chickened out.
Oh, guys, the internet's not working. Yeah, I'm not sure what happened. My internet was fine, but StreamYard just said that.
Yeah, blame it on others. I understand.
All right, so what was I saying? So this configuration is going to do a couple of things. It'll install the definition of the bucket. It'll install those two sort of variants of compositions for it, the Terraform-based one and the native one. And then it's going to pull in all of its dependencies as well. In this case, it depends on provider Terraform for the Terraform-based composition, and it depends on provider GCP for the GCP-based configuration composition. So if we do kubectl get configuration package, hopefully it's going to say that Tulti, that's good. If we do kubectl get provider package, we should see, yep, it's pulled in the latest provider GCP and the latest provider Terraform. So kubectl get XRD for the composite results. You can see we've got what was it? Kubectl explain was something you used the other day, Victor, that I always forget.
Yes, explain will give you just the name. So yeah.
There you go. So this is going to tell us about the bucket XR that we've installed. It doesn't tell us very much though, unfortunately. I'm not sure how to.
Sorry, there is a flag to do it recursively. This shows you only the I forgot recursive.
Nice. Oh yeah.
Now it makes sense.
Nice. Yeah, we can start to see a little bit more detail there. We've got our location thing that I spoke about before. And also just to show you a bit behind the scenes. Go ahead.
We have accumulated questions. Shall we go through them now?
Yes.
Or you wanna wait until the end?
No. Let's okay. Those questions.
So Nathan, what if the state is locked by a crashed Terraform plan? Actually, that's a good question, which I guess probably we are still too early for that.
Yeah, pretty much. I mean, just to set context there, this provider was launched yesterday as experimental, so it is definitely not bulletproof software at the moment. Yes, if the state is locked via a crash process, then you would have to unlock it manually at the moment. And that's actually there's something that's mentioned on the README at the moment. Because we run Terraform all the time, there is actually a timeout flag to the provider that you can control. And by default, it's 20 minutes, which is fairly generous, but sometimes, a big Terraform module can take forever to apply. So that's something to be conscious of as well. If you time out, if you take longer than 20 minutes or whatever you set the timeout flag to, we'll just kill the Terraform process and you will end up with a locked state and you'll have to go and look into that.
And another one from Carlos. What happens in a scenario that Terraform determines a replacement of a resource?
Yeah, that is a pretty good. Yeah, that's a really good question as well. So there is a difference between, I think, what Carlos is asking here, there's a difference between how Terraform does this and Crossplane does this. If you ask Crossplane to update an immutable field on a resource, it just doesn't update it. It just says, no, that field's immutable. I'm just not going to change it. If you ask Terraform to change an immutable field, it will recreate that resource. It will say, hey, I need to go delete this resource and recreate it in order to make this update. And typically this is okay with Terraform because it's expecting a human to be there supervising everything that it does all the time. So it's going to say, hey, I'm going to go do this. Do you want me to do this? Whereas Crossplane, it expects to be unsupervised. You need to be careful at the moment is the long shot. We run Terraform, apply with auto approve on. So if it was going to go and delete and recreate a resource, it would just do that. So one feature that I want to write up an issue is I would like to actually make that configurable, basically. I think we could add a flag to the provider that says, if you think you're going to go destroy something, don't proceed, basically, stop and give some feedback. So today, as a version 0.1.2, it would just destroy things if you made a change that would require a destroy. So do keep that in mind. But again, I think that we can, at the very least, updated to have a sort of conservative mode where it would just say, nope, I'm not going to destroy anything unless you're literally deleting the workspace. Crossplane. Oh, I can't hear you, Victor.
My mic was muted. I don't know how that happened.
Back.
I don't know how long I was speaking with muted mic. Anyway, the Crossplane is GA summary, and how to migrate from Terraform to Crossplane is what Nick is explaining, and it's still early stage, right? This is not the final, everything figured out type of stuff.
Yeah, definitely. There's a subtle distinction with Crossplane. Crossplane itself is GA. Providers in varying states of maturity sort of thing. So, there's AWS provider, GCP, now Terraform provider, SQL provider. They're all sort of decoupled maturity-wise from Crossplane. I think Victor has included a bunch of links in the description of this video, potentially, that
yes,
has some other information about migrating from Terraform, previous talks and things like that.
All the links, I will show some of the links down, but all the links will be in the description after this video, after we finish streaming.
Nice.
Okay, back to your terminal. I'll interrupt you when there are new questions.
Sounds good. All right, where are we?
There's nothing better than interrupting other people.
So let's just, first thing I'm going to do is set up the provider config for Terraform. If you've used a provider config in Crossplane before, this looks pretty familiar. There's one kind of interesting difference about this. Most provider configs in Crossplane only have one credential. So like GCP, for instance, you'll say this provider config provides like the JSON blob of GCP service account credentials that Crossplane uses to go and talk to GCP and ask it to do things. Because a Terraform workspace can itself have multiple providers, the provider sort of inception that we were talking about before, you can actually provide multiple credentials here. In this case, we're not. We're just providing one because we're using the GCP provider of Terraform. But so anyway, we're just going to kubectl apply. Remember the -f flag provider config. So it's going to go create that default provider config that our Terraform provider is going to go use. And then, as we said before, we've got the XRD there for buckets, and we should have two compositions, one for GCP implementation of this and one for a Terraform implementation of this. So at the moment of truth, let's go apply our bucket. So this is now creating our bucket abstraction that we as the platform team have defined. This is kind of simulating what our customers would do, what our software engineers would do if they wanted a bucket. This might take a moment, but if we follow the links here, you should be able to kubectl describe the bucket. And then you can see that this has actually gone and made a composite bucket, which is kind of the actual composite resource, which is sort of behind the scenes machinery. So let's go have a look at that composite bucket. Oops, that's not a file. Key that I want. Composite bucket. Oh no, so I put this together at the last minute and it is not working as I would want, as I expected. Let's see.
Whomever thought that you're not human now is disproven.
spec.source required value. I know what's going on there. So what I'm going to do is delete this bucket for the moment, and I'm going to delete config -f. All right. Get rid of that provider package. I'm going to go in here, and I'm going to go into the Terraform composition. And here's what's wrong. I forgot to tell it this is in fact a remote source, so I'm just going to put that in there, that required field. And then I should just be able to, I know where. I'm just going to build that configuration. Oop. What do you like about that now? That I'm not in the configuration directory. Build this configuration. You can see there's now duplicate packages. Configuration. You can now see a configuration package, and I'll just push that configuration up to registry. And then here, I should be able to install that configuration. And that should be pulling down. This one. All right, let's see if we have a remote source. That's promising. Hopefully my file works now. So I'm gonna apply the provider config again, which doesn't exist because I'm in the wrong directory. Oh, come on. Blame my new keyboard. Yes, apply the provider config. Apply the bucket. Have a look at that composite bucket. Hooray! Actually worked this time. Well, so far, it's getting there. So let's see if we have a workspace. You can see that it's made a workspace, Terraform workspace here. Let's see if that workspace is UCP credentials not found. So this is interesting. Let's go to, this is actually creating, oh, I know what it's doing. So this is the Terraform that's actually being run. And foolish me oops. Created this provider config, which pulls its credentials from this secret, which does not exist, fortunately. A script that will do this because I have to do this a lot. Just wait a few seconds. Should be able to. Secret now exists. It'll get there. It's just waiting to.
It pains me to watch you doing that. Type watch in front of that command, please.
The problem is my terminal is not big enough, right?
Ah, okay.
Yeah.
Yeah, I understand now. My bad.
Ah, there we go. Done.
Hey.
Resource. So now let me pull out a tab and send it over to the window that you all can see. And get in there. Oh, don't fine, just hang out there. Let's see. So this should have actually created a secret for this resource as well, if I understand correctly. Namespace. I think it's called the secret example machine because I copied one from a VM. It's not in fact a machine; it's a bucket. But let's just gloss over that for the moment. Okay, and according to this, our bucket should be named Crossplane-example Crossplane workspace, Terraform.workspace, and the Terraform workspace will be the external name of our resource. So, see that my So you can see that the external name of our resource is cool bucket. So here we go. We have Crossplane example cool bucket. So that has now been created. And so that basically is, again, using your example, your existing Terraform workspace, so your existing Terraform module for buckets behind a Crossplane composite resource. So that's kind of step one in the migration. Take your existing module, take your existing workspace, put it behind a composite resource, and offer it as self-service to your users, so they can now go and create their bucket composite resource, their nice simple abstraction, and have that use Terraform behind the scenes. And you can sort of plumb through. You can patch in variables. So you can basically take the fields, as we showed, like the location field of your bucket composite resource, of your bucket abstraction, that gets fed into the variables of the Terraform workspace. So you can sort of influence things that way. And you can also pull out the outputs of the Terraform resource as well. They'll get written to a connection secret. So just anything you declare as a Terraform output. We have the URL, which is probably why address wasn't working for me as a field name, because it's actually called URL, which has just the link to the bucket that'll get output in the connection secret. So that is step one. Any questions built up, Victor, before I move on to
here's from Nick. Could someone elaborate on how Crossplane manages the state of given resources? For example, if a pod dies, Kubernetes can reschedule it. And I guess it's a two-part question. The Crossplane resources themselves, they're Kubernetes resources like anything else, right? And they just follow the same rules as anything else in Kubernetes. And then outside of the cluster, the infrastructure, right? Crossplane is doing something similar to what Kubernetes is doing to pods, right? If it gets deleted. Now, I'm not sure about Terraform part of this story, but for normal providers, if something gets removed, changed, no matter what, Crossplane will always try to reconcile it to the desired state specified in your manifest.
Yeah, exactly. So as Victor said, first you tell Crossplane what your declarative state is by applying, YAML file or calling the Kubernetes API. And then on Crossplane will sit and watch that desired state, and every couple of seconds, it'll basically try and make the real world look that way. And what it actually does for each resource individually, which is kind of nice because Terraform does this as a whole, but Crossplane does it sort of more granularly for each resource. It will observe as its first step. It'll always look at what's happening in the world. and it can find out a couple of things that it needs to do. First, it could look and just be like, oh, yep, it's already how you want it to be, so then it just does nothing. It could look at it and say, oh, it exists and you want it to be deleted, so it will delete it. It could look at it and say, oh, it doesn't exist anymore. Got deleted somehow out of band, so I'll go recreate it. Or it could say it does exist, but it's different than how I want, so I'll change it effectively. One place that it does differ, as I said before with Terraform, is the only time it won't change it is if you try to change something that's immutable. Crossplane, unlike Terraform, it won't just go and delete it and recreate it. It'll say you have to actually ask me to delete it and then recreate it with different properties in order to do that.
Okay, and here's the, I think we already answered it in a way, right? If somebody deletes a bucket outside Terraform state file, Terraform can reprovision it during an apply. And that's in case of Terraform. In case of Crossplane, Crossplane is doing that all the time, constantly. I mean, constantly, with few seconds delay between iterations, right?
Yeah, exactly. I would argue that this is the strength of Crossplanes because like you say, in Terraform, you kind of someone would have to go and run Terraform apply, so it could potentially be days or, until someone notices, whereas Crossplane will effectively, instantly, within seconds, notice it's gone and recreate it for you.
I mean, it's conceptually, it is the same like Kubernetes itself, or let's say in AWS, running VMs directly or through autoscaling groups, right? Autoscaling group in AWS will make sure that specific number of VMs with specific what's or not will always be running. Right.
Yeah, exactly.
So Terraform is like creating VMs directly, and then the Crossplane is like autoscaling groups.
Yeah.
Okay. More. There is more questions. I guess the better, right? And if I update the Terraform module, how do I notify Crossplane to reconcile?
You don't have to. It just will.
And now this is for my question, actually, for Unique. I understand for inline, but for remote, is it also periodically checking that Git repo or whatever the remote state is, right? It's not caching it or anything like that.
It's a bit of both. It does get cached locally, but on every reconcile, it pulls it down from the remote module as well. It kind of has just a temporary on disk cache to actually like run Terraform. So
okay, more. You will have to answer this one.
Yeah, provider maturity. It's a number of axes that you could basically say one is number of resources, but just having every resource in the world, they could be unproven in alpha. So it is both how many resources we support and the stability of those resources. And interestingly, there's almost two axes of stability as well, right? One is API stability, which is roughly, do we feel confident that we're not going to make any changes to the shape of the API and that you can trust that like that, won't change. And the other one is just, how proven are these resources? Have we given them time to soak? Do we think that they're buggy? We always introduce new resources as alpha, basically. So it'll be, bucket /v1 alpha 1 as the version, which is basically just a policy that we assume it's alpha until we've run it for a while and got no complaints, and then eventually, once we feel good about the API and that we got the right API, we feel good that we're not getting hundreds of bug reports about it. Then it gets to graduate to beta, and then it gets to graduate to V1 on a resource by resource basis. And then I would imagine once we have enough V1 resources in a particular provider, that provider would be eligible to go V1. We don't actually have any V1 providers at this point, but we're pretty close on a number of fronts.
Hey, if Gmail could have was in beta for like decade, we can be in beta for a while longer as well.
Right. Well, I mean, relevant to this source material, Terraform went V1 like a couple of weeks ago, and they've been for almost a decade or something now, at least 5 years.
That's all with the questions. Do you have anything else planned to show?
Yeah, I want to just wrap up with the final stage of this, which is another part that has been untested. So we showed using Terraform behind the scenes. I just want to prove the point here that because we've got, again.
Oh, wait, I'm not sharing your screen. It's coming up. Here we are.
There we go. So we've got the two compositions. So this is the two kind of implementations of this bucket, right? And what we just demonstrated was using the Terraform one, the tf.compositebuckets.example.org. So that is the one that goes and applies that Terraform workspace. But let's say you've been doing that for a while and you've written now your native Crossplane GCP provider. This does not use Terraform behind the scenes. It uses a native Crossplane provider that's all sort of idiomatic Crossplane Go and patterns and practices, a nice actually schemified API that's not just sort of an opaque blob of HCL behind the scenes. You've got this going and you're ready to try it out and move people over to this. The really nice thing with Crossplane, that's just sort of a feature of Crossplane or Composition, is that you can just go to your bucket.yaml, or your users can go to this bucket.yaml. Exactly as we said before, users, as far as they know, they've just been asking for a bucket. They don't really have to know about whether Terraform is being used to make it, or Crossplane's being, native Crossplane providers being used to make it, or whether, a Jira ticket gets raised behind the scenes every 30 seconds and some poor SRE is rapidly making changes. We don't actually have a Jira ticket provider yet, but that would be pretty funny. But the nice thing with Crossplane is that with changing nothing else, you could basically just say, okay, customers, tell it you want GCP now, and it'll go and use the native provider instead of the Terraform one. You could call this provider native if you wanted to as well. You also don't necessarily even need your users to make this change. You can actually set a default provider that is used for all buckets, so they could just omit this entire composition selector, and behind the scenes you could change the default to be native now, and everyone would just get native ones. So this is another one where I haven't actually tested this composition yet, so let's give this a shot. I previously deleted the bucket we had before, so we should see that we have shouldn't have any Terraform workspaces at the moment. I'm going to apply this bucket, and now we should have, it's needing a little bit of a spurious modification notifications, but we should have right, that looks promising. This is storage. Aha. I know what I've done
Found
here.
it.
I think, slightly concerning. Apparently, I don't have permission.
Maybe, yeah, sorry.
Go ahead.
I thought since we have quite a few questions left, maybe we can dedicate the last few minutes to the questions.
Yeah, sounds good. I will just make the point that if I had IAM permissions to create buckets, that would have worked. So that's the of not testing there. But effectively, that was then going, and that created a native Crossplane managed resource for a bucket and was trying to reconcile it, which is failing because I gave it an IAM service account that didn't have the right permissions. So let's move on to the remaining questions.
Yes. So let's go with this one. This one is big, I guess. Advantages: Crossplane versus Terraform. I'm going to be quiet here because I made video on that subject. So if I say anything, I will send a link.
I mean, I'm pretty biased about this as spent the last 2 years building Crossplane. So I think there's a new number of things, right? One is that Crossplane is always on. And again, there's a couple of blog posts about this and other videos that go into this in much more details. But one, Crossplane is always on. So one of the issues you'll find with Terraform is just that some people have trouble with it because if they haven't plumbed it up to like a cron job or CI/CD or something like that, it gets run by an SRE every now and again, And often the scope of what's being applied is quite big. It's Terraform. You need to be quite conscious to design it to say only update this or only update that. It always wants to like build a whole DAG, a whole graph of resources, and apply the world all at once every time you invoke Terraform. And you can end up in this weird space where, like, if you only do that every couple of weeks and you haven't been super disciplined, and every now and again someone goes and tweaks something or changes something outside of Terraform, you're going to go run Terraform apply because you just updated, let's say, your database and you want to go add some storage to your database or add a replica or something like that. But someone changed your cache out of band, and suddenly you're trying to Terraform apply, and it's changing both. Like, you're like, I didn't want my cache to change. I didn't know this was going to happen, but now I have to. I can't change my bucket until I change it. I can't change my database until I change my cache. And some people are like, oh, this is just too hairy. This kind of this, like, it's too hard, it's too scary to run Terraform apply, so I just won't. With Crossplane, we're almost a little bit more adventurous with which maybe not a word you want to hear, but we sit there and we always reconcile. So, like, if someone goes and changes that cache, seconds later we'll change it back. We're just like, no, we've declared the state of the world. Same as how Victor said with autoscaling groups works. Same as how Kubernetes works, sort of thing. If you say there's going to be a deployment of 4 pods and you delete a pod, Kubernetes recreates the pod. That's how we approach things. I think another really nice thing is that the interface to Terraform it's a CLI, like it's a configuration file. Like, if you want 10 developers to use it, they all need to go get the CLI, have it on their laptops, or have it on some machine they can reach, or put it behind Jenkins or something like that. Nice thing with Crossplane is that Crossplane is an API. So it's, people think of it as Kubernetes and they might think of it as YAML files, but it's really just a REST API, right? You can just go and offer it as a service, build a web dashboard around it, put Argo CD in front of it to sort of make it GitOps enabled, all kinds of interaction styles. And it's basically you've got Crossplane in the middle, you've got an API coming into Crossplane, and Crossplane like talks to other APIs and orchestrates other systems. So the nice thing is that, Crossplane and Terraform, there's tons of ways that they can integrate with each other as well. You could put Terraform in front of Crossplane. You could have a Crossplane provider for Terraform that went and did things to Crossplane. As we're demonstrating today, you have a Terraform provider for Crossplane that goes and, has Terraform on the back end.
I think it's kind of like in a way, a paradigm shift, right? And it reminds me of the difference between CI tools and what we're seeing right now with tools like GitOps tools like Argo CD and Flux, right? Where CI tools normally react to your reactions, right? You as a person, you decide to do something, to push something to a Git repository, and that generates chain reaction of, okay, so if you decided to do this, I'm going to do this, and that, right? While on the other hand, and this is not only Crossplane, it's like Argo CD uses the same logic. Hey, I'm not going to react to what you're doing, but rather I will make sure that the desired state and the actual state are always in sync. So kind of I'm monitoring both sides of the fence in a way, right?
Yeah. Yeah, and I think one final thing that is getting a kind of, is maybe an advanced use case of Crossplane, but when people really get into it, that I really love personally about Crossplane is that you can kind of do self-service with Terraform, right? You can write a module that's like my company's RDS module, my company's database module, or whatever. Give that to everyone, but that module has kind of its own inputs and outputs, its own sort of opinionated like shape. It's very obvious that you're using that module. Crossplane has, in the composition layer, has something that, if you're familiar with like programming interfaces, works a lot like that. You could just say, here's the shape of the inputs and outputs of this general concept that I've defined, like a bucket or a database or whatever is your organization needs. And then you can have multiple different implementations of that. You can have the Google implementation, the AWS implementation, or in this case, we showed the Terraform implementation versus the native Google implementation sort of thing. And this helps with the separation of concerns, because as far as the folks consuming this who are doing self-service are concerned, they're just using your company's kind of bucket, and you can change whether that's powered by Terraform or Google or AWS or whatever behind the scenes without them needing to, obviously if you move from S3 to GCS or vice versa or whatever, they're probably going to notice that in some way, but they don't have to go and like learn a new configuration language. They can just change a flag to say, give me the AWS one now, sort of thing. And it's very simple for them. So I think, in addition to being API driven, Crossplane does a lot more with regards to abstraction and really enabling self-service. It's a tool that you can give to your engineers to let them help themselves while enforcing your opinions. It's not a CLI tool that you run when someone raises a Jira ticket saying, please give me a database or something like that.
Okay, Carlos, and I don't know that one. I'm guessing that you're outputting Terraform output to std out, right? And then it can be picked up by whatever.
We actually don't surface that at the moment, but that is definitely something I'd like to add. I think it would be very useful. I am curious about how to do that in a nice way, because I'm a big believer in not expecting people to go and look at the logs of cross-plane providers and whatnot, because again, with this separation of concerns, I would imagine, the platform team and the cross-plane operators would have access to those logs, but the average user who's just saying, give me a bucket, I wouldn't expect them to have access to the logs. So it would be interesting to take those things and maybe put them in the status of the resource if we could make them succinct enough, or write them to a config map or something. I think it's a good idea, and I think we should look into doing it. I don't have a perfect solution right now as to how we would do it. But definitely, hit me up on Slack afterwards if you've got some good ideas about what a good user experience for that would be.
Then we have another one, which I guess is the subject of today's session, right? How to start transition from Terraform to Crossplane, which is, I'm guessing, a correct me, Nick, either what you just showed or rewrite your HCL into Terraform composition. I mean, eventually you have to rewrite, right? It's just a question whether you start by rewriting or start by importing Terraform into Crossplane.
Yeah, exactly. And long term, we have plenty of ideas as to how to automate this and make it a smoother process. I could imagine a panacea where you just say, hey, Crossplane, here's all of my infrastructure in the cloud at the moment. Just go, download that and start managing it. I think we'll get there one day, but we're not there yet. So today, I would say, historically, what folks have done is pick, if they're using a lot of Terraform, pick one resource, start small, and move that over to Crossplane, get used to Crossplane, learn its features, build trust in it, and then slowly increase, the amount of infrastructure, move things over a piece at a time. And again, just as we've demonstrated today, now one thing you can do is you could use your existing Terraform and effectively use that as your Crossplane provider, and just use the Crossplane abstraction layer on top to sort of get used to that, to learn one part of Crossplane while mostly still trusting Terraform with things. And then once you're comfortable with that, then start moving the behind the scenes implementation details over to native Crossplane providers.
Okay, there's more. In case you did delete, I guess it's the same thing as anything in Kubernetes, right? If you delete the controller, there is the resources that it created, which, except that in case of Crossplane, those resources are outside the cluster. Or if you delete a service in Kubernetes that happens to be type load balancer, then load balancer is gone as well, right?
Well, Terraform, so it sounds like Carlos might be kind of familiar with this. So Crossplane has a field on every managed resource, including the new Terraform workspace, called the deletion policy. And the deletion policy by default is delete, which basically means you delete the workspace, and we'll call Terraform destroy to destroy all the infrastructure. Similarly, like with the native bucket example, you delete the native bucket, and we'll actually go call a Google API and say, hey, delete that bucket. But you can change that policy to orphan, and it will just orphan it instead. So if you change it to orphan, it will not call Terraform destroy. It'll just never call the delete thing. It'll just be like, oh, okay, I'm just going to stop managing this and leave it there. Same with the bucket sort of thing.
Does Crossplane provide access to, I would guess, cloud resource logs that has been provisioned using Crossplane?
I'm not sure if I quite get the question, but if you're saying sort of the logs of things that have changed, let's say you make a bucket in Google will usually produce some audit logs that say a bucket's being created. It doesn't currently let you access those things. It does keep its own audit trail though, in the form of Kubernetes events. So you can go and see, you can do sort of kubectl get events and see all the stuff that Crossplane has done recently. It's just, if your goal is to be able to see a log of what Crossplane is doing, we do that. It's just in the Kubernetes API rather than in the cloud. You could separately out of band go and look at your cloud audit logs as well. Crossplane just doesn't have a functionality for surfacing those to you at the moment.
And the last one, which doesn't mean that people will not post more. Do you support JSON apart from HCL? I'm so curious about this question because I never saw JSON in Terraform.
You know, Carlos, I actually don't remember. I wrote most provider Terraform maybe 2 months ago and then picked it up again like last week. I know that for variable files, there's a flag where you can say the variable files are in like tfrs.json instead of regular tfrs. I don't 100% remember whether I did that for the inline module as well, but it should be possible. It's either supported or easy to support and should be supported.
Okay, this was the last question, and we happen to be exactly the closing time. So, Nick, if you have last thoughts, I'm going to count to 3 or shut you down.
I will just say if anyone wants to chat about this or has ideas, the repo is github.com/crossplane-contrib/provider Terraform. Please come and raise issues and try it out. And please feel free to, I'm NEGZ on Slack, on Crossplane Slack. Come say hi and let me know your thoughts and let me know if you have anything you want from the provider.
Yeah, and also come to Slack and then ask anything. Right? I'm not sure what is the address, but you'll find it. Crossplane, just Google Crossplane Slack.
All right, thanks, Victor.
Thank you all for listening to us. Cheers.
Bye.